to try and get through this as quickly as possible. So you may have to slow down the video to a lower speed because of the speed I'm going at. So the base of the common logarithm is 10. The base of the natural logarithm is e. The common log is just written as a regular log, and the natural log is written as ln. Okay, so starting with our transformations, the first one is a square root function. So this is a reflection over the x-axis because of that negative, a vertical stretch by 3 because of that 3 out front, and then up 4 because that 4 is on the outside of the radical. So our next one, this is again the parent function of the square root of x. This is a parent function of 1 over x. And so these transformations are a vertical stretch by 2 because of that 2 up top. Then we're going to the right 7 because of this 7, and then we're also going up 10. Okay, so this is a parent function of x to the third. So that 3 is a vertical stretch by 3. That 4 inside is going to the left 4. Again, it's the opposite of what we think. And then again, this is another where the parent function is 1 over x. So that 1 in the numerator doesn't really give us anything. So this minus 2 means we're going to the right 2. And then this plus 1 means we're going up 1. Okay, so going on to the next section, we are finding the following, stating the domain of each of the new functions except for the composition. So we're starting with the first one. We're doing f plus g. So this is f and this is g. So all that means is we're going to go ahead and we're going to add those together. Minus x minus 12 plus x plus 3. We'll simplify that. So we'll get x squared. The x's will end up canceling. And then negative 12 plus 3 is negative 9. That is a function. You can stop there. There's no radicals or fractions, so the domain is negative infinity to infinity. So f minus g, we would do x squared minus x minus 12. We do need to subtract and put parentheses around that g equation so that we can make sure we distribute that negative to the g equation. So it'd be x squared minus x minus 12 minus x minus 3 because that negative is going to both pieces of g. So again, we'd combine our like terms, so we'd get x squared, the negative x's would combine to give us negative 2x, and then negative 12 minus 3 is negative 15. Again, no fractions or radicals, so the domain is still negative infinity to infinity. Ooh, this cord is bugging me. Okay. So the next one we're doing multiplication, and so because we're multiplying these, the setup looks like this, but to help us multiply it out, we are going to go ahead and use the box. So we'll put x plus 3 on the side, and then we'll put x squared minus x minus 12 up here, and we'll multiply it out. So x squared times x is x to the third. This would be 3x squared. This would be negative x squared. This would be negative 3x. This would be negative 12x, and this would be negative 36. So then we just pull all that out. So x to the third can't be combined with anything. The negative x squared and the 3x squared would combine to give us 2x squared. The negative 3x and the negative 12 would be negative 15x, and then we'd have minus 36. Again, no fractions or radicals, so domain is negative infinity to infinity. Okay, so the next one, our setup is going to be f over g. So we do x squared minus x minus 12 over x plus 3. So because of that x plus 3 right off the bat, we can state that the domain is that x cannot equal negative 3, because if x was negative 3, then that denominator would be 0, and that's not okay. We do need to check if anything's going to cancel, so I do need to factor that numerator. So again, I'd go ahead and put that in the box, but this time we'd go from inside to outside. So I want something that multiplies to negative 12x squared, but adds to that middle term of negative x. So the two numbers that are going to do that are negative 4x and a positive 3x. So this would be x minus 4, x plus 3. And again, we should hopefully see that, okay, these two are the same factors, so therefore they're going to cancel out. So our answer is just going to be x minus 4, again with that domain restriction that x cannot equal negative 3, because even though those canceled, that created a hole, and x still cannot equal negative 3. So this would be our answer. So f of g of x, so this means we're doing f of g of x, Okay, so that means into f we're plugging in x plus 3. So in this equation, everywhere we see an x, we're going to substitute it in with x plus 3. So we'd say x plus 3 squared minus x plus 3 minus 12. And then we do have to simplify. So to multiply out that x plus 3, you may need to use the box to help you, right? Because that's technically x plus 3 times x plus 3. So please make sure you're careful there. So this would be x squared, 3x, 3x, and 9. So this first piece is really becoming x squared plus 6x plus 9, because we're combining those 3 x's together. I distribute that negative, so it'd be minus x minus 3, and then still minus 12. And then we just combine our like terms. So the x squared can't be combined with anything, so we'd bring that down. The 6x and the negative x would give us 5x. And then 9 minus 3 is going to be 6, minus 12 is going to be negative 6. You do not need to factor it, and it's also a composition, so you don't need to state the domain. Okay, for the next one, we're doing f of g of 1, and you have two options here. You can plug in 1 into this equation, but I'm going to kind of do it the other way just to show us how. So first we would find g of 1, and so into the g equation, I would plug in 1. So 1 plus 3, that's going to give me 4. So that means instead of finding f of g of 1, I'm really trying to find f of 4, because that output I would plug in. So then into the f equation, I'm going to plug in 4. So 4 squared minus 4 minus 12. So 16 minus 4 minus 12. So that's going to end up being 0. Okay, which is okay. 0 is a viable answer. So when you're plugging in a number, you should get out a number. When you're plugging in x, your final equation should be in terms of x. So the fact that we got out 0 is totally fine. Again, that's a composition. We don't need to state the domain. So next we're going to use the graphs to evaluate the function. So this first one, what we're really looking for is f of 1 plus g of 1. So we'd go over to our graph and we'd look at 1, and we'd look at the graph of f, and we'd figure out what that y value is. That y value is negative 1. And then we'd go and we'd look at the value of g. That value of g is 2. So we do negative 1 plus 2, so the answer is just 1. Again, similarly, we're really doing f of 2 minus g of 2. So we'd go over to 2. F of 2 is that y value of 1. G of 2 is going to be that y value of 2. So we're subtracting 2. So the answer would be negative 1 there. This one is f times g, so we're finding f of negative 2 times g of negative 2. So again, we'd go over to negative 2. F is actually the upper one here, so that value is 2. And g of negative 2 is here, that value is 1. So the answer would be 2. Here we're doing f divided by g, so we do f of negative 1 divided by g of negative 1. So f of negative 1 is this graph. Again, that's going to be 0. Oh, I'm kind of running out of room. And g of negative 1 is 1. So it's 0 over 1. So the answer to that one is 0. And then we do f of 0 divided by g of 0. F of 0 is negative 1. G of 0 is 0. Negative 1 over 0, this one is going to be undefined because we cannot divide by 0. And then finding f of g of negative 2, we're really looking for this. So we again start by finding g of negative 2. So that's going to be 1. We see from our graph, because we go to negative 2 and we go to g, that's 1. So we're really looking for f of 1. And so then we go over to 1, and that's going to be negative 1. So that is our answer. Okay, so when finding inverse functions, the equation is similar to this. F of x and y are somewhat interchangeable. And so when we try to find inverse functions, the first thing that we do is we actually flip x and y. So we would write this as x equals 3 minus y over 2y. And then we want to solve for y. So I'd multiply both sides by 2y. So I'd get 2xy equals 3 minus y. I want to get all the y's on one side, so I am going to go ahead and add y to both sides. I can't combine these because this one has an x and this one doesn't. So I would say 2xy plus y equals 3. So I can't combine those, but what I can do is I can actually factor out a y so that this becomes 2x plus 1. Note, you do still need to put that placeholder 1 there because this technically has a coefficient of 1 out front. And then once I do that, I can divide by 2x plus 1. And just a reminder, whenever we write our final answer, we want to write it in F inverse notation. So F inverse of x equals 3 over 2x plus 1. And typically speaking, we do want to state the domain restrictions. So again, our denominator can't equal 0. So in this situation, x cannot equal negative 1/2. Okay, and I got that by setting the denominator equal to 0 and solving. So again, this equation is technically set up like this. But we want to find the inverse, so we flip x and y. So we say x equals 2y cubed plus 5, and we solve for y. So we'd start by subtracting 5. We divide both sides by 2. So we'd get x minus 5 over 2 equals y cubed. And then to get rid of that cube, we're going to go ahead and take the cube root. So that would cancel this out here, so that would get us our final equation. F inverse of x is equal to the cube root of x minus 5 over 2. And cube roots, their domain is negative infinity to infinity, so there's really no restrictions on that one. Okay, next page. Okay. Suppose the graph of a function f is given. How would you obtain this? Well, that 2 out front is giving you a vertical stretch by 2. Okay. That x minus 1 inside the parentheses, that's the opposite of what we think, so we're actually going to the right one. And then that plus 5 on the outside means we're going up 5. Again, here that negative out front is going to be a reflection over the x-axis. That x plus 3 in the parentheses, again, opposite of what we think, so we're actually going to the left 3. Okay. So now we're getting to graphing. We want to state the transformations, the domain, range, and the y-intercepts. So one thing we need to remember for these types of parent functions is that the parent function points are 0, 1, 1 comma b, and then negative 1, 1 over b, and where b is referring to the base there. So this one you may want to rewrite because we have a negative exponent, so you can think about that in two different ways. You can think about that as a reflection over the y-axis, because that's what that is, or you can think about that as a or you can rewrite it if you'd like. I'm going to do it as a reflection over the y-axis. So this one, this negative x, means that this transformation is a reflection over the y-axis because it's next to the x rather than out front. And then that plus 3 on the outside means we're going up 3. So my parent function points, my base here is 4. So my parent function points are going to be 0, 1, 1 comma 4, and then negative 1, 1/4. Again, following this pattern. So I'm going to go ahead and plot those parent functions. For these types of graphs, the domain is always negative infinity to infinity. And then the range is, typically speaking, the asymptote and above or the asymptote and below. And so we'll talk about that in a minute. I am going to go ahead and graph it first. So again, I'm going to plot the parent function 0, 1, 1, 4, negative 1, 1/4. So this is the parent function. And then we are reflecting that over the y-axis, so over this one, and then shifting it up 3. So I'm going to take 0, 1. If I reflect it, it's not going anywhere, so it's just going to shift up 3, so it'll be here. 1, 4 would reflect to be negative 1, 4. And then it's going to move up 3. 1, 2. It goes a little off my graph, but that's okay. Okay. And then this one would reflect over the y-axis. That would get me here, and then it'd go up 1, 2, 3. So it's going to be here. And so the graph looks like this. And so because I shifted up 3, there is a vertical asymptote there that we maybe don't see. The vertical asymptote, horizontal asymptote. I'm moving so quick. The horizontal asymptote starts at 0 and then shifts up and down with our graph. So because we went up 3, that horizontal asymptote went up 3, so it's going to be y equals 3. which therefore helps us with our range because we didn't reflect over the x-axis, so our range is going to be from that horizontal asymptote onto infinity. Oh, it's with a parenthesis, I'm sorry. I need to get my white out. Just to make this a little prettier. Because it's never actually going to touch that asymptote, and so that's why we need to put a parenthesis around it rather than a bracket. And again, that asymptote's happening here at y equals 3. So we've done domain, range, we've even added the horizontal asymptote there. We still want to find the y-intercept. You can find that by looking at the graph, but I'm going to find it algebraically as well. So remember, when we find the y-intercept, we plug in 0. So this would simplify to 4 to the 0th plus 3. Anything to the 0th power is 1. So we're going to get 4 there. So that means our y-intercept, again, we always want to write it as a coordinate point, it's going to be 0, 4. Okay, so moving on to the next one. Here we have a little bit of a different situation. So this one, that 2 out front, that is a vertical stretch by 2. These are my transformations. This 1/2 is the base, so we're not worried about that. This x plus 2, that means we're shifting the opposite of what we think, so we're going to the left 2. And then out here, this means that we're going down 2. So our base is 1/2. And so that means our parent function points are going to be 0, 1, 1 comma the base, and then it's 1 comma 1 over the base, which if we do 1 over 1/2, that's the same as multiplying by the reciprocal, so it's like 1 times 2 over 1, so it's just going to end up being 2. So the parent function point here is going to be -1, 2. Okay, so I am going to go ahead and plot those, so 0, 1, 1, 1/2, -1, 2. So again, my domain is always going to be -infinity to infinity for these types of graphs. My range is again going to shift with the graph. So I didn't reflect over the x-axis, so therefore it's not going to be like -infinity to a number, it's going to be a number to infinity, and I'm shifting down 2. So that means that that horizontal asymptote is also going to shift down 2, so it's going to be y equals -2. So that graph is shifting down 2, so my range is going to be -2 to infinity. Again, those start at 0 and they shift up and down with our graph. So I am going to go ahead and plot that. So again, 0, 1, if I vertically stretch that, I'm going to multiply the y values by 2. So that's going to be 0, 2, and then I'll shift that to the left 2 and down 2. So it's going to end up here. Okay. If I shift 1, 1/2, I vertically stretch that by 2, so it actually become 1, 1. Because 1/2 times 2 is 1, and then it would go to the left 2 and down 2. And then if I change -1, 2, if I vertically stretch that by 2, it'd be -1, 4, because again we're multiplying the y values by 2. And then I'd go left 2 and down 2, so that'll take me here. Again, our asymptote is at -2, so that's a dotted line right here. And so when we draw our graph, we want to make sure that we do not cross that dotted line. So it should look something like that. It doesn't show us our y-intercept here, so we do need to find it. So I'm going to go ahead and plug in 0 to make that happen. So I'm doing 2 times 1/2, 0 plus 2 is going to be squared, which means I'm doing 2 times 1/4, right? Because 1 squared is 1 and 2 squared is 4. Minus 2. So this 2 times 1/4 is really 1/2. So 1/2 minus 2 is going to be a -3/2. Because we could rewrite -2 as -4 over 2. So that means my y-intercept is going to be 0, -3/2. Okay. Moving on to the next one. So the next one says to simplify, so I'm multiplying these out. I'm going to use the box to do so. So I'm doing 2 times 3 square root 5, or 2 plus 3 square root 5 times 4 minus square root 5. So 2 times 4 is simple, it's going to be 8. We can only multiply outside with outside and inside with inside, so 4 times 3 is going to be 12, and then we'll keep the square root of 5. 2 times negative square root of 5 is negative 2 square root of 5. And then this one, we do the square root of 5 times the square root of 5. You can think of this two ways. That's going to be the square root of 25, so that'll cancel and give us just 5, or you can think if I do a radical 5 times a radical 5, the radicals cancel, it's just going to be 5. So we're really doing 5 times 3 plus this negative, so it's end up going to be negative 15. So then we take that out, so 8 minus 15 is going to be negative 7, and then we can combine these together as well. 12 minus 2 is going to be 10, and then square root 5. Okay. So when, again, I'm squaring, we're still using the box here. So we're doing 3 minus the square root of 7 times 3 minus the square root of 7. 3 times 3 is 9. This would be negative 3 square root 7. This would also be negative 3 square root 7 because I can't combine those. And then again, the square root of 7 times the square root of 7 is going to be the square root of 49, which is just 7. And the negatives will also cancel. So 9 plus 7, that's going to give us 16. And then we're combining these two together, so it's going to be minus 6 square root 7. So moving on to these, we need to remember our exponent rules. So log base 2 of 8. I can rewrite 8 with a base of 2 if I write it as 2 to the third. So that log base 2 and that 2 would cancel. So the answer to this one's just 3. Log base 10 of 10. Again, this is like having an exponent of 1. So the answer to this is just 1. Log base anything of itself is always going to be 1. Log base 3 of 81, of 1 over 81. So the fact, I do equals. So the fact that it's a fraction means the exponent's going to be negative. We can rewrite 81 as 3 to the 4th, but because it's a fraction, it would be 3 to the negative 4th. Again, those log bases would cancel, so the answer is negative 4. This is 4, log base 4 of 1. Even though it's written in a different order, the log base 4 and the 4 still cancel, so this is still equal to 1. Log of 1,000, this is like saying log base 10. So we can rewrite 1,000 as 10 to the third. So again, that log base 10 and that 10 would cancel, so the answer is going to be 3. This one, we already have it rewritten for us, which is nice. So log base 2 of 2 to the third, the log base 2 and the 2 will cancel, so this is just 3. This one you may need to be a little bit careful with. I would set this one equal to x. And so then if we remember, we can rewrite logs. So this would become the base of the exponent on the other side. So we would get that 81 equals the square root of 9 to the x. And hopefully we also remember that we can rewrite square roots as exponent over index. So the exponent here is 1 and the index is 2. So this is technically 9 to the 1/2 x. So then we can rewrite 81 with a base of 9. That'd be 9 squared. And now that I have the same base, I can set the exponents equal. So I can do 2 equals 1/2 x multiplied by 2. And that would give me that x equals 4. So this is equal to 4. For this one, again, the natural log and the e are going to cancel. So we're really doing 3 times 4. So this one is going to be 12. This one, the natural log of e is just 1. So this would just be 7. And again, I would probably rewrite this one. So I'd set it equal to x. I'd rewrite it. So we're really doing 64 equals, again, I'm going to make this the base of the exponent on the other side, the 7th root of 4 to the x. And again, I can rewrite that as exponent over index. So the exponent is 1, the index is 7, so 1/7 x. Then I can rewrite 64 with a base of 4. That's going to be 4 to the 3rd. And so now that I have the same bases, I can set the exponents equal to one another. So then I'd multiply by 7, and I'd get that x equals 21. Okay. Next section. Okay, so determine the domain, range, zeros, vertical asymptotes, and transformations. So I'm actually going to start with the transformations. This is log base 10, and it's moving to the left 7. Okay. And so what that means for the domain starts at 0 to infinity. So because I'm moving to the left 7, the domain moves to the left 7. The range is always going to be negative infinity to infinity. the vertical asymptote also moves to the left 7. So that means it's going to be x equals -7. And then the zeros we get by setting this equal to 0 and solving. Okay, so in order to make that happen for the zeros, we would x plus 7 equals 0. So we want to rewrite it. So this would be x plus 7 equals 10 to the 0th. And again, 10 to the 0th is going to be 1. So we'd subtract 7. So we'd get that x equals -6. So our 0 is going to be, I'm going to write it down here. Our 0 is going to be -6, 0. Okay. So the next one, we are shifting. This one is not in the parentheses, so therefore it's up and down. We're shifting down 1. So that means for our domain, it's not going to shift left or right, so it's going to stay as 0 to infinity. Our range, again, is always going to be -infinity to infinity for logs. Our vertical asymptote, again, because we didn't shift left or right, is going to be x equals 0. And again, to find our zeros, we're going to set this equation equal to 0. So I'm going to run out a little bit of room. So I'm going to say log of x minus 1 equals 0. So this time I would have to add 1 first. So I would say log of x equals 1, and then I would rewrite it. Again, this is base 10, so this is going to be x equals 10 to the first, because I'm making that base the base of the exponent on the other side. So that means it'd be x equals 10. So the 0 here is going to be 10, 0. Okay. So the next one, transformations here, we have the base of the natural log for this one, but the 3 is a vertical stretch by 3. Again, that plus 1 is not in the parentheses. That means this is moving up 1. The domain is still going to be 0 to infinity because it's not moving to the left or the right. The range is still going to be -infinity to infinity, and the vertical asymptote is still going to be x equals 0 because we're not moving to the left or to the right. We're just moving up or down. Again, to find the zeros, we would set this equal to 0, and we'd solve. So we'd subtract 1. So we get 3 ln x equals -1. And then we would divide by 3. Oh, I'm so not going to have room for that last one. Okay. And then we would, again, make the base of the exponent on the other side. So if we do that, the base would be e. So our 0 is going to be e to the -1/3, 0. Or you could also write that as 1 over e to the 1/3. So just know that those are interchangeable because, again, the final exam is multiple choice. So it's important to know that those are the same thing. So both of these are correct, but it would probably be listed like that on your test. Okay, last one. Again, we have a log base 10. We are shifting to the right 2 because it's inside the parentheses. That means our domain is going to shift to the right 2. Our range is staying as -infinity to infinity. And then our vertical asymptote is also going to shift to the right 2. And so then for our 0, we would say log of x plus 2 equals 0. Or I'm sorry, x minus 2 equals 0. So again, we'd make the base of the log the base of the exponent on the other side. So that would give us x minus 2 equals 10 to the 0th. Anything to the 0th power is always 1. And so then we would add 2. So we would get that x equals 3. So our 0 here is going to be 3, 0. Okay. Okay, so we are expanding each of these. So if we hopefully remember, when we expand with multiplication, we can rewrite that as separate logs through addition. So please make sure you separate that log 12 as well. That's still being multiplied by something. So we'd say log 12 plus log of x to the 5th plus log of y to the negative second. And then those exponents can become coefficients. So this would be log 12 plus 5 log x minus 2 log y. Additionally, for this, when we do division, we use that as subtraction. So this one we would separate as ln of the numerator, which is positive, minus the natural log of 4, and I can rewrite the cube root of y again as exponent over index y to the 1/3. We're not quite done because we still want to separate this out further. We can't separate this first one because they're split by addition, so that one is going to stay the same. And then the second one, they're both negative. So when I split them up, I need to make sure they both stay negative. You can think of this as two things, like distributing a negative. So you could write this as negative, and then these are being multiplied together. So this would be the natural log of 4 plus the natural log of y to the 1/3. You just need to make sure that negative goes to both pieces. So again, those exponents can become coefficients, and I'm also going to distribute the negative. So this would be minus the natural log of 4 minus, again, that exponent becomes a coefficient, 1/3 the natural log of y. Okay, so when we are condensing, we're going the opposite direction. So first we want to start by making that coefficient an exponent. So this would be log base 8 of 9x, that both of those squared, minus log base 8 of 2x minus 5. I am going to simplify that in the next step. And then this subtraction means that it's going to be division. So that numerator, I'm going to simplify. 9 squared is 81, and then x squared is x squared. And then this part is going to go in the denominator because it is negative. So this is going to be 2x minus 5. And once we get it down to one singular log, we're done. So again, in the next one, the positives go in the numerator, the negatives go in the denominator. So first thing I'm going to do is make sure I turn those coefficients into exponents. And so then the positives go in the numerator, the negatives would go in the denominator. So this would turn into ln 13, because that's positive, a to the 7th, because that's positive, c, because that's positive, all over b to the 11th, because that one is the negative piece. So it should go in the denominator. Okay, so the next one says write the set of logs in increasing order. So we want to go ahead and simplify this. So log base 5 of 55, I can't really simplify. That's going to kind of stay the same. Hopefully we know that the square root of 100 is going to be log base 5 of 10. And then 3 log base 5 of 75. That 3 in the coefficient can become an exponent. Cube root of 75. And so the cube and the cube root are going to cancel, so this is just going to become log base 5 of 75. So that means in increasing order, this one would go first, this one would go second, because 55 is next, and then 75 is third. And we want to write them in order of the originals. So we'd write this one first. So log base 5 of the square root of 100, log base 5 of 55, and then log base 5 of, 3 log base 5 of the cube root of 75. Okay, so next thing that we're doing is solving. So when we're trying to solve a square root, we start by, for this one, we want to get rid of that square root because it's already alone, so we can go ahead and square both sides. So we have x minus 5 equals 2 squared, which is 4. And then we'd add 5 to both sides, and so we'd get that x equals 9. But we do always want to check for extraneous solutions, so we'd plug that back in. 9 minus 5 equals 2. 9 minus 5 is 4. Is the square root of 4 2? Yes, it is, so this is a good answer. For the next one, we would need to exponentiate first. So because this natural log is log base e, we want to make both sides an exponent with a base of e. So then this e and this natural log cancel, and we get 5x, and on the other side we get e to the 7th. So to solve that, we would divide by 5, and so x would equal e to the 7th over 5. We do kind of need to check this one, but really what we want to check here is that we're not taking the log of a negative number, and if I did plug that in, I wouldn't be taking the log of a negative number, so it's fine. The next one, again, we're going to go ahead. We have that cube root alone, so we can go ahead and cube both sides. So this would give us x minus 6. Negative 3 to the third is negative 27. We'd add 6 to both sides, and so we'd get that x equals negative 21, and again, we do want to check it. So the cube root of negative 21 minus 6 equals negative 3. So this is saying the cube root of negative 27 equals negative 3, and it does. So we're good there. Okay, so next we want to simplify. So here we have the fifth root of x to the fourth to the fifth. So that fifth root and that exponent of 5 would actually end up canceling, so this is just going to be x to the fourth. For this one, remember we're seeing how many times it divides nicely and then leaving what's left over. So 7 divides nicely by 5 once, and then it would have a remainder of 2. 22 divides nicely by 5 4 times, right, because 20 divides nicely, 20 divided by 5 is 4, so we would be able to take out a y to the fourth, and we would have a y squared, we'd have 2 left over. And this is an odd root, so we don't need to worry about absolute value. Okay. So for the next one, if we're taking the cube root of 32, we want to find the highest cube root that's existing in 32. And so the highest cube root would probably be 8, and 8 times 4 gives us 32. So the cube root of 8 and the cube root of 4, we can split this up. The cube root of 8 is 2, so this is going to be 2 cube root 4. So for the next one, again, we have a negative exponent, so that means that the 64 is actually in the denominator, and then we can make that exponent positive. We can also rewrite that exponent as a radical. So we're exponent over index, so we're taking the cube root of 64 squared. Actually, I'm going to rewrite this a different way. So that's one way that you can do it. Another way that you can do it is we can rewrite 64 as 4 to the third. So we'd be doing 4 to the third to the 2/3. So 3 times 2/3 is just going to give us 2. So this would end up being 1 over 4 squared, which is going to be 1 over 16. Okay, so again, for the next one, we're going to rewrite as exponent over index. So if I have the fourth root of x squared, that's like x to the 2/4. This is the square root of x to the fourth, so this would be x to the 4/2. And this would be the fourth root of x to the 8, so this would be x to the 8/4. So we can kind of simplify these a little bit, right, because 2/4 is going to be 1/2, 4/2 is going to be 2, and 8/4 is going to be 2, so hopefully we see that these x squareds would cancel, and so we would really get x to the 1/2 as our answer. You can also add and subtract exponents, but I think canceling is probably the easiest part there. Okay, so again, rewriting in radical form, exponent over index, so we're taking the fifth root of x to the third, and so you can write it like this, or it can also be represented like this. This one we're writing as an exponent, so the exponent is technically 1 there, so it would be 7 to the 1/3. Okay, graph each of the following, state the transformations in order, zeros, y-intercepts, domain, and range. Okay, so the transformations, that negative is giving us a reflection over the x-axis, and then we're moving to the left 2 and down 4. I guess I'll do domain next. So domain is typically going to, it usually starts at 0 to infinity, but because we shifted to the left 2, it's actually going to be negative 2 to infinity with a bracket. Range is going to typically start again at 0 to infinity, but we reflected over the x-axis, so that means it's actually going to start at negative infinity. And then we also went down 4, so it's going until negative 4. So, let's see. Do I want to find the 0 or the y-intercept? Yeah, I guess I'll do 0. So to find the 0, again, we'd set this equal to 0 and solve. So we'd add 4. We'd have to probably divide by negative 1 first. We'd square both sides. So it'd be x plus 2 equals 16, and then subtract 2, so x equals 14. And then again, we still do want to check this. Hmm, 14 plus 2. And so this is saying the negative square root of 16 minus 4 equals 0, but this would be negative 4 minus 4, which is not the case. So for this one, there actually is no 0. So this does not work, it's extraneous. And we'll also see that when we graph. And then again, to find the y-intercept, we plug in 0 and simplify. And so there's not a whole lot to do to simplify this. It would just have to stay as this. So the y-intercept is going to be 0, comma, negative square root of 2 minus 4. Okay. For square roots like this one, our parent function points are 0, 0, 1, 1, 4, 2, and then also 9, 3. So I'm going to plot those parent function points before I transform, which 9, 3 doesn't really fit on our graph, but we do still want to think about it when we're doing our transformations. So 0, 0 isn't really going to reflect over the x-axis, so it's just going to move left 2 and down 4. 1, 1, if I reflect over the x-axis, would be 1, negative 1, so it's going to go left 2 and down 4. And then 4, 2, if I reflect that over the x-axis, it's going to be 4, negative 2, and then it's going to go left 2 and down 4. And so this is what our graph would look like. I would also check that with your domain and range, 2 to infinity, negative infinity to negative 4. We're good to go. Okay, so this one is a cube root graph. And the transformations at 2 out front tells us that we are doing a vertical stretch by 2. And then we're moving to the left one and down 3. And also on the last one, for negative, or for 9, 3, it'd be 9, negative 3. And then if I move to the left 2, it wouldn't get me still onto the graph. So that's why I didn't plot that one. For cube roots, which we know it's a cube root because of this 3 up here, the domain and the range are negative infinity to infinity. So to find the zeros, again, we're going to set this equal to 0 and solve. So I'd add 3. I divide by 2. And then I'd cube both sides. So I'd get x plus 1 on this side, 3 cubed is 27, 2 cubed is 8, and then I would subtract 1. So I'm subtracting like 8 over 8 technically, if that's how you want to think about it. So this would be x equals 19 over 8. So that means that my 0 is going to be 19 over 8 comma 0. And then again, to find that y-intercept, I'm going to plug in 0. So I'd say 2 times the cube root of 0 plus 1 minus 3. And because the domain is negative infinity to infinity, I don't really need to check cube roots just because of that domain. So it would still end up working out. So if I plug in 0, I'm taking the cube root of 1. The cube root of 1 is just going to be 1, so 2 times 1 minus 3, so that'd be 2 minus 3, which is negative 1. So that means my y-intercept is 0, negative 1. So the parent function points for this one are 0, 0, 1, 1, 8, 2, negative 1, negative 1, and negative 8, negative 2. Which again, these two aren't really fitting on this graph, but just do know that those exist. So 0, 0, 1, 1, negative 1, negative 1, 8, 2, negative 8, negative 2. So this is my parent function. And then we want to transform it. So if I vertically stretch 0, 0, it's not really going anywhere, so it's just going to go to the left 1 and down 3. If I vertically stretch negative 1, negative 1, it would become, by 2, it would become negative 1, negative 2, and then that's going to go to the left 1 and down 3. So it would be here. If I vertically stretch 1, 1, again, we're multiplying the y value, so that's going to become 1, 2. And then it would go to the left 1 and down 3. That's also the same as our y-intercept, so that's good. That means we're on the right track. And 8, 2, even if we transformed it, would not fit on our graph. So this would be our final graph, and it would look something like that. Okay. State the domain and range. So again, this is a square root function, so the domain starts at 0 to infinity and then moves left and right with our graph, but this is not moving to the left or right, so the domain is going to be still 0 to infinity. The range moves up and down with our graph, but we also have a reflection over the x-axis, so that reflection means our range is actually starting at negative infinity and going until that shift. So it's going up 4, so it's going until 4. And then for cube roots, the domain for both of those is going to be negative infinity to infinity. Okay. We want to find the radius of the circle, so we need to simplify this. So we would add 9 to both sides, and I'm also going to rewrite this. So this would be x squared minus 8x plus y squared plus 10y equals 9. So then we want to do new parent function. So looking at these first two, we should hopefully, one sec, notice that, like, if we did new parent function where we took out an x and did x minus 8, the zeros would be 0 and 8, so we divide that by 2, we'd get that it's 4. So that's a shift to the right 4, which we want to write as x minus 4 squared. But technically we just added 16 to this side, so we need to add 16 to the other side. And similarly with the y's, again, if you want to think about new parent function, this would be y times y plus 10. So our zeros are 0 and negative 10. So our axis of symmetry is negative 5. That's a shift to the left 5. And so we're going to write that as y plus 5 squared. But technically we just added 5 squared, which is 25. So 9 plus 16 plus 25 is 50. And if we remember, our equation is x minus h squared plus y minus k squared equals r squared. So that means that that 50 is equal to the radius squared. So we'd have to take the square root of that in order to find the radius. And so 50 can be split up into 25 and 2. The square root of 25 is 5, and it'd be the square root of 2. So our radius is 5 square root 2. Okay, so writing in logarithmic form, the base of the exponent becomes the base of the log on the other side, so it'd be log base w of d equals c. And make sure that is smaller and you can tell that it's a base. So converting to degrees, if we have 3 pi over 15, we want to multiply by 180 over pi. So the pi's would cancel, which we should hopefully notice. And then you can simplify in steps. I would probably start by saying both of these are divisible by 3. So this is 5, and this would be 60. And then both of these are divisible by 5. So this would end up being 1, and then this would end up being 12. And so then you really only need to do 3 times 12, which is 36 degrees. So then converting 65 to radians, we'd multiply by pi over 180. So both 65 and 180 are divisible by 5, so that's going to give us, I believe, 36 and, 13? Yeah, I think that's right. 36 and 13, and then those don't actually simplify any further, so our answer would be 13 pi over 36. So then we're stating 2 positive and 2 negative angles that are coterminal. So coterminal angles are when we add or subtract 2 pi. So to find, I'm going to start by finding the positive one. So if I have 5 pi over 18, I want to start by adding 2 pi, which we would need to get a common denominator for that. So I would do 2 times 18, so that's going to be 36. So I'm adding 36 pi over 18. So one of our coterminal angles that is positive is going to be 41 pi over 18. So this would be one of them. So to find the next one, if I want to find 2, I would add 2 pi again. So I would add 36 pi over 18 again. And so that would give me, what, 77 pi over 18. So these would be two positive ones. And then to find the negative ones, I would do 5 pi over 18, and I would subtract that 2 pi, or that 36 pi over 18. So one of my negative ones would be negative 31 pi over 18. Yeah, that's right. So this would be one of them, and to find another, again, we would subtract 36 pi over 18 from that. So this would be negative 67 pi over 18. Oh, you can't see that. There it is. Okay. Whew, still so much to do. Okay. Giving the exact value, these you really need to just look at the unit circle and study. The exact value of cosine of pi over 4 is going to be 1 over the square root of 2. Sine of pi over 4 is 1 over the square root of 2. Sine of pi over 3 is the cube root of 3 over 2. Cosine of pi over 6 is also the cube root of 3 over 2. Sine of pi over 2 is going to be 1, and cosine of 0 is also 1. So just study the unit circle for those. For this one, if I'm given that sine is equal to 1/5, I want to go ahead and draw a triangle and label theta. So sine is the opposite over the hypotenuse, so that gives me that. I want to find my missing side, so I'm going to call this x. So we'd say x squared plus 1 squared equals 5 squared. So we'd get x squared plus 1 equals 25. So that means that my missing side is going to be the square root of 24, which we do want to simplify. 24 splits into 4 and 6. So the square root of 4 is 2, so it's going to be 2 root 6. So to find cosine of theta, we would do the adjacent, which is 2 root 6, over the hypotenuse. And to find tangent of theta, we would do the opposite, which is 1 over the adjacent, 2 root 6. So describing the shifts, if it helps you, you can also rewrite this as sine of 3 times x plus pi over 12 minus 2. This is the same thing. So the shifts here are a shift up 2, and then our phase shift is, up 2. It's going down 2 because it's negative. Down 2, and then our phase, so this is our vertical shift, and then our phase shift is going to be to the left, pi over 12. That 3 is changing our period, so we're not really going to worry about that. So write a possible equation. So first thing we want to do is identify one period. So if we're starting here, which I typically want to start at 0 if I can, then we want to, one period is going to be once the graph starts to repeat. So it starts to repeat right about here, so that's going to be one period of the graph. And so because this starts at that, at that reference line and then goes up, we're working with a sine graph, and again, because it goes up, it's going to be a positive sine graph. So if this is pi over 4, then each of these tick marks we're adding pi over 4, so this would be 2 pi over 4, which is the same as pi over 2. This would be 3 pi over 4, and then this would be 4 pi over 4, which is going to be pi. So that means that our period is pi, and we calculate the period by doing 2 pi divided by b. So if our period is pi, then that means that b has to equal 2. So we have a sine graph with the b value of 2, and then the amplitude is from that reference line to the top, or halfway the distance between the highest and lowest values, so our amplitude is going to be 2. So our function we can write as f of x, or we can write as y, is 2. Again, we're going up, so it's going to be a positive sine value. The period is 2. And we're not shifting left, right, up, or down, so it's just going to be 2x. Okay, the amplitude of this, that's coming from the number out front. The amplitude's 4. So write a possible equation to represent the graph. This one, hopefully we notice we're shifting down. Again, we typically want to start at 0 if we can, and then where the graph starts repeating, that's where we're going to stop. So this is going to be one period. Hopefully we can look at that and notice that that is actually a cosine graph, because it's not starting on the reference line. Because the reference line, the line that kind of splits it in half, is happening right here at -3. So because that reference line is at -3, we're actually shifting down 3. And so we can calculate a few things from here. So again, from that reference line to the top is 2, so that means our amplitude is 2. We are starting below that reference line, so that means this is actually a negative cosine. And again, it tells us that our period is pi. So that means that, again, that would be 2 pi over b. So that means b is, again, still 2. So we would write our equation. We're not shifting left and right because, again, we started at 0. So we would say f of x equals negative, the amplitude, which is 2, cosine of b, which is 2x, again, because we're not shifting left and right, and then we're going down 3. Whew, okay. So next we are doing the calculator active section. I'm actually going to do the calculator active section in a separate video. That's what I'll do. So I'm actually going to jump to 55 because these are non-calculator. So I want to get through those first because I don't have enough time to get through everything. So if we could all jump to 55, this is in the non-calculator active section. So we are trying the graph of f times g of x if this is x plus 2 and this is 2x minus 1. So f times g means that we're going to be multiplying these two together, so x plus 2 times 2x minus 1. So I would use the box to go ahead and do that. So this would be 2x squared, 4x, negative x, and negative 2. So it would be 2x squared. We can combine these x's together to give us plus 3x, and then minus 2. So this is a parabola, so this answer would be, oh, nope, not D. I read it wrong, right? Wrote it right, read it wrong. It's actually C. Okay. So the next one says, given these two, find f of g of x. So we want, or g of f of x. So that means into g, we are plugging in f of x, which is x squared minus 1. So everywhere we see an x and g, we're going to plug in x squared minus 1. So 3 times x squared minus 1, we do want to distribute that, so it's going to be 3x squared minus 3, so it's going to be a. So then we want to find, using this figure, f plus g of 6. This light one, this is f of x, and the darker colored one is g of x. So we're really finding f of 6 plus g of 6. 1, 2, 3, 4, 5, 6. So this is 6. So f of 6 is going to be negative 1, 2, 3, 4, 5, negative 5. And then we're adding to that g of 6, which is 1, 2, 3, 4, 5 as well. So those are going to end up canceling. The answer is going to be 0. Okay. Then I'm finding f of g of negative 5. So again, we're going to start by finding g of negative 5 first. So 1, 2, 3, 4. Ooh. I need to look at that because 1, 2, 3, 4, 5 would actually take us. Oh, okay. I see it. I see it. Okay. F. Ooh, give me a second, y'all. Just kidding, I messed you up. This is not labeled super great, I'm going to be real honest. Okay, the lighter graph is actually g, so this one is actually g of x, and the darker graph is actually f of x. Sorry, I definitely read that wrong, but it wasn't super clear in my opinion. So the last one isn't really going to be affected like that, because really all it's going to change is that we're doing g of 6 plus really all it's going to change is what we're plugging in here. So our answer is still going to be 0. So f of 6 is actually going to be positive 5. And then g of 6 is actually going to be the negative 5. But we'll still get the same answer there. So this one, if I'm finding g of negative 5, that's going to be up here. 1, 2, 3, 4, 5, 6. So it's actually going to be 6. So I'm finding f of 6. So f of 6 is going to be 1, 2, 3, 4, 5. So this one is going to be D. And then again, if I want to find an inverse, the way that I do that is if this is the original equation, I'm going to flip x and y and solve for y. So I'd say x equals 2y minus 3. So I'd add 3 to both sides. So x plus 3 equals 2y, and then divide by 2. So, and again, we want to write it as f inverse of x equals x plus 3 over 2. That's lining up with C. So, last one, we want to find the radius of the circle. So I'm going to start by adding 45 to the other side, and then I'm going to kind of rewrite. So I have 3x squared plus 12x plus 3y squared minus 6y equals 45. So I do want to factor out a 3 out of here, so this would be x squared plus 12x. So again, I'll worry about that actually in a minute. And I also want to take out a 3 out of the y's. Okay. So what this means is that for this one, again, our zeros would be 0 and negative 12. Our axis of symmetry is going to be negative 6, but that's a shift to the left 6, which we'll write as x plus 6 squared. But instead of just adding 36, we actually added 36 times 3, which should actually add 108. Okay. And here, again, we should get, squared, we should get that this is y minus 1 squared, but instead of just adding 1, right, but keep in mind negative 1 squared is a positive 1, we actually added 3. And so we just need to make sure that we're multiplying by that coefficient. So then 45 plus 108 plus 3, so this would be 111, 156. Yeah. So then we can actually go ahead and divide everything by 3 to kind of get rid of those coefficients. So we'd have x plus 6 squared plus y minus 1 squared equals 52. And again, for that equation, that r squared is going to be equal to 52, so we want to take the square root of both sides in order to solve that. So we'd get that r equals, I think I might have messed up my math somewhere. Give me one. I did. Sorry guys, I'm going so fast, I'm losing my mind. I took a 3 out here, but didn't take a 3 out here. So I need to fix that. I thought that number was kind of big. Okay, so when I take a 3 away from that 12, it's actually going to be 4x, so this would actually turn into x plus 2 squared. So instead of adding 4, I actually added 4 times 3, so I actually added 12 to this. So ignore all of this. Okay, so 15, so this would be 60. My whiteout does not want to white out today. So this would be 60, so we would divide that by 3, which should give us 20. Okay, so r squared is equal to 20, so we take the square root of that, which 20 can be split into 4 and 5. The square root of 4 is 2, so this would be 2 square root 5, so the answer is actually B. Okay, so that finishes us for the non-calculator section. I will make a separate video for the calculator section.